we're going to rationalize the denominators, which means we're going to get the radicals out of the bottom of the fractions. Now, each of these have a single term radical in the denominator, which means we don't have any other radicals being added or subtracted to our radical. So the way you rationalize this type of fraction is rationalize the denominator is that you're going to multiply the top and the bottom by the value, the same value on the top and bottom, but it's the value that's going to make the bottom radical disappear. So for the first problem, we have the square root of 2 over the square root of 7. We need to get rid of the square root on the bottom. If we multiplied the bottom by another square root, that's the same as squaring the square root of 7, and that would get rid of the radical. Okay, so it's determined that we must multiply the bottom by the square root of 7. So if we multiply the bottom of this fraction by the square root of 7, we have to multiply the top by the very same thing. We don't want to change the value of the original problem, that's why. Okay, so on the top we can multiply under a single radical sign, square root sign, 2 times 7. And on the bottom, just as we suspected, we have the square root of 7 raised to the second power, which cancels out the radical and the square and the square root. And see what it does? It gets rid of the radical on the bottom, which is exactly what we were trying to do. On the top we have the square root of 14. We cannot simplify that because there's no perfect square factor in 14, so we are finished with this problem. No more radical. Okay, a similar case is part B, where we have 3 over the square root of 8x. Okay, so we're going to write the problem again, and then we're going to figure out what do we need to multiply the bottom by to get rid of the square root sign. And I say we need to multiply it by the square root of 8x. Let's try it. Top and bottom multiplied by the square root of 8x. Okay, so that gives us on the top 3 times the square root of 8x over, now here's the trick, the square root of 8x times itself is just squared. Then we can cancel the square root and the square and get rid of the radical. So here's our answer with no radical in the bottom. We can simplify this further because we can factor a perfect square factor out of the 8 under the radical sign, 4. And then we can bust it apart. 3 times the square root of 4 times the square root of 2x over 8x. I mean, we don't have a radical on the bottom anymore. We're just simplifying the radical upstairs. The evaluation of the square root of 4 on top is 2. So it's 3 times 2 times the square root of 2x over 8x. And that's equal to 3 times the square root of 2x over 4x. You'll notice the 4 and the 2 cannot cancel upstairs and downstairs because the 2 is under the radical. It cannot cancel with anything outside of the radical. The same thing for the x under the radical. It doesn't simplify with anything outside of the square root. Part C, we've got 2 times the square root of 3 over the square root of 7. Now we need to get the square root of 7 out of the bottom, so rewrite the question and ask yourself, what must I multiply the bottom by to get rid of the square root? The square root of 7. So do that on the top and bottom. Wow, doesn't this look familiar? It looks a lot like the one upstairs on part A, but it's a little bit different. Our final answer is 2 times the square root of 21 over 7. And we have no more radical in the denominator. Very good. And we simplified the top. All right, finally, we have a tall square root of 4 over x. Now, you might look at this and go, what are you worried about? There's no radical in the bottom there. Well, yeah, there is. We're going to bust up the radical top and bottom on the fraction. Square root of 4 over the square root of x. That's the square root of 4 on the top over the square root of x. Well, there's a radical in the bottom there. Let's simplify the square root of 4 on the top. It's equal to 2 over that square root of x. Okay, so the square root of x is the problem. We need to get rid of the radical. What must we multiply the bottom by to get rid of the radical in the square root of x? And the answer is the square root of x. So you must multiply by the same thing on the top and bottom. We get 2 times the square root of x on the top, and we get the square root of x squared on the bottom, which cancels the square and the square root, and we have no more radical on the bottom. We just have 2 square root of x over x, and we know we cannot simplify the x's because one's under the radical sign and the other's not, so they don't associate with each other.